Hi friends, how are you? I hope you and your family are doing well. Dear friends, in our previous lecture, we discussed about Heisenberg uncertainty principle. Dear friends, today we will discuss about quantum picture of material particle, that is wave packet. In our previous lecture, we came to know that a moving material particle has wave nature also. So, matter has dual wave particle nature. According to de Broglie hypothesis, the wavelength of the wave associated with a material particle moving with a velocity v and having mass m is given by lambda is equal to h by mv, and it is equation 1, where h is Planck's constant. If capital E is the energy of the particle and nu is the frequency of the wave, then according to Max Planck's quantum theory, E is equal to h nu. So nu is equal to E by h, that is equation 2. According to Einstein's mass energy relation, we know that E is equal to mc square, where c is the velocity of light. If we put this value of E is equal to mc square in equation 2, we will get nu is equal to mc square by h, and this is equation 3. De Broglie wave velocity or phase velocity is given by small u is equal to nu lambda. Nu is frequency and lambda is wavelength. So it will be equal to mc square by h into h by mv. So we will get u is equal to c square by v, and it is equation 4. But according to Einstein's theory of relativity, the speed of a material particle v is always less than the speed of light c. But according to equation 4, the de Broglie wave velocity must be greater than c, which is not expected. And second is what? The de Broglie wave associated with the particle would travel faster than the particle itself, thus leaving the particle far behind. Thus, it is clear that a material particle can't be equivalent to a single wave train. Schrödinger resolved these difficulties by postulating that a material particle in motion is equivalent to a wave packet rather than a single wave. Now discuss what is wave packet. This is a general graph for wave packet. A wave packet comprises a group of waves, each with slightly different velocity and wavelength, with phases and amplitude so chosen that they interfere constructively over only a small region of space where the particle can be located, outside of which they produce destructive interference, so that the amplitude reduces to zero rapidly. The amplitude of one-dimensional wave packet in general resembles the curve of the figure above. Such a packet moves with its own velocity g, called the group velocity. The individual wave forming the packet possesses an average velocity u, called the phase velocity. If nu is frequency and small u the phase velocity, then omega is equal to 2 pi nu. It is equation 5. And u is equal to nu lambda. It is equation 6. Group velocity capital G is equal to d omega by dk. It is equation 7, where k is wave propagation constant and k is equal to omega by u. If we put the value of omega and k in equation 7, then we will get g is equal to d omega by d omega by u, closed in a small bracket. And here we have put value of omega 2 pi nu. Then we get d nu by d a small bracket nu by u a small bracket closed. And so 1 by g is equal to d a small bracket nu by u a small bracket closed by d nu is equal to d a small bracket 1 by lambda by d nu. If E and capital V represent the total energy and the total potential energy of the particle respectively, we have half of mv square is equal to capital E minus capital V, where a small v is the particle velocity. So small v is equal to middle bracket 2 small bracket e minus capital V small bracket closed by m middle bracket closed to the power 1 by 2. It is equation 9. And 1 by lambda is equal to mb by h. So m by h into middle bracket 2 into a small bracket e minus capital V a small bracket closed by m middle bracket closed to the power 1 by 2. It is equation 10. Substituting this in equation 8, the group velocity is given by 1 by g is equal to d by d nu big bracket m by h middle bracket 2 a small bracket e minus b a small bracket closed by m middle bracket closed to the power 1 by 2 and big bracket closed. So if we will put the value of e is equal to h nu and solving this equation, and finally we will get 1 by g is equal to 1 by v. We finally come to the conclusion that the group velocity g is equal to the particle velocity v, and it is equation 11. Thus a material particle in motion is equal to a group of waves or a wave packet. But there is a serious difficulty against the concept of a wave packet, since a wave packet is in general very soon dissipated. For example, if we produce a wave crest at any point on a smooth surface of water, it spreads out and dissipates in a very short time. Thus, if a material particle is considered to be a wave packet, it is necessary to postulate the existence of a guiding wave, for it is described by Schrödinger equation. Without this assumption, the wave packet theory is untenable. The physical significance of Schrödinger equation is that it relates the amplitude of the guiding wave to the probability of finding a material particle at a point. If the amplitude of the guiding wave is 0 at a certain point in space, the probability of finding material particle at this point is infinitesimal. The mechanical process is accompanied by a wave process, the square of whose amplitude gives a measure of probability of the event taking place at the point considered. As the value of amplitude is small at all points except in the wave packet. Hence, the probability of finding the particle within the region of the packet is maximum. Thus, it is possible to find an equivalent particle in the region of the wave packet which travel with the group velocity v. Conclusively, we can say the wave packet plus guiding wave possess the properties of a particle moving with velocity v and exhibits interference and diffraction phenomena. Thus, the difficulty is resolved. So, I hope, dear friends, you have understand the wave packet and how the difficulty in assuming a single wave as particle was resolved. Dear friends, I would like to thanks to you for watching the video by spending your valuable time. I request, please like, subscribe and share the channel so that you will get more notification for our further lectures.